So, good afternoon, everyone. We are going to present our mini project, which is disaster management SMS alert system using Arduino, which is done by myself, who is Janvi Panambur, and my teammate Purvaja Rao. This project is guided by Professor Harshali Mane, and let's begin then. Next, please. So this is the outline of the project. So first topics, that is introduction, literature survey, gap identification, problem statement and objectives, and proposed methodology will be explained by me. And the next part, that is requirement analysis, impact analysis, professional ethical practices to be followed, system implementation, results and discussion, conclusions and future scope, and references will be explained by my partner Purvaja Rao. Next, please. So let's introduce our topic. So, what is a disaster? A disaster is a natural calamity which can occur anytime and anywhere. So it can cause a major destruction and a major harm to humanity and other properties. For example, buildings are lost, then homes are lost, and there is a major impact on the society because of a single disaster. So, a disaster can be very harmful. In short, it is a disaster. So, there are many types of disaster. For example, flood, earthquakes, then soil erosion, and many such kind of disasters. And it has a very major impact on our lives. For example, earthquake. Let's take an example of earthquake. So, an earthquake can be very destructive. For example, it just destroys the total, what we can say, community in a particular area, and it can cause a major amount of destruction. So it's better to just take some steps to stop those calamities, but as you all know, we can't stop it. So it's better to just put an alert system instead. For example, we can just alert or make sure that the people who are staying in the particular area know that a particular incident is about to occur, which will automatically uh, introduce an alertness among the people. Next slide, please. It was a, okay. Okay, so we have done the literature survey among some of the articles. So the first article is of uh, Angelo A. and Beltran Jr. and Keith Joseph et al. Okay, I'm not reading the names. So these are the literature surveys which we have basically done. So the first survey is based on an alarm system which uh, alerts the residents staying in the particular area by getting the data from different kind of sensors and intimating the residents staying in that area by showing an SMS to them. Uh, okay, so the next one is a journal from 2016. So this is the disaster management system on mobile phones using Google Map. So this is the system where a Google Map, everyone knows that it is a Google Map, the app. So, sorry. So, this app provides a proper, you can say, proper location of the calamity which is going to occur in a particular area. So, this app just provides the proper information that this calamity is going to occur in this area by detecting the changes in the climatic conditions. So, next, please, Purvaja. So this is these are the last two journals which we have studied. So the first one is in the international journal, where the system detects the landslide, tsunami, and the earthquakes. And as in the other journals, the common topic in this literature survey is that it intimates the disaster which is about to occur. So, in this paper, they have detected the landslide, tsunami, and earthquake and intimated accordingly. And the last one is 2014 journal, where they have introduced a Google Map and Android mobile phone application. So, in the similar way, they have used the Google Maps and they have indicated the disaster which was about to occur in that area. Next, please. So these are the main characteristic which actually needs to be implemented. So gap identification is uh, the gap which needs to be filled. So these three are the main targeted uh, points which need to be implemented. So the first one is to deliver real time and accurate data. So basically, our project should aim on providing proper and accurate data according to the life conditions. For example, if a data is provided and it is actually coming from some time before, so it doesn't just makes any sense. So basically, the data provided should be real time and accurate. Next is to spread the alertness. So basically, the disaster management should be done accordingly that people know that a calamity is about to occur. So an awareness has to be created among the people staying in that particular area, and so alertness is required within this kind of project, that is disaster management projects. And automation is also to be included. So automation is basically, there shouldn't be any requirement of um, you can say, maintenance and all those things. So for that, automation is required for the project, so that to inculcate an automated process which is not handled by any humans. Next, please. Okay. So problem statement and objectives. So our problem statement is to build a cost-effective alert system which provides real-time data of natural disaster occurring in nearby surrounding. So it means that we have to provide a proper alerting system, which should also be affordable, basically. So our main topic is to make it affordable and more convenient to use. So our system is the, you can say, the best at right now. And the objectives is to spread alertness and awareness of the disaster through SMS, and it should be easy to implement, as I said. And it is also low cost, and as it is low cost, so it is easily accessible. So these were the main objectives. So yeah. Okay, next please. Raja. So this is the proposed methodology of our project, which is the stepwise process. So the first step which occurs is the data acquisition. So these are the four, some of the sensors which I have mentioned. So the first sensor is vibration sensor, which detects the vibration which is occurring in a particular area. Next is the humidity sensor, which detects the humidity change in the climatic conditions. Next is the temperature sensor, which detects the temperature. And next is rain sensor, which checks the precipitation value, and it then acts accordingly. And the last one is the GPS module. So this module basically tracks the location of the various places. So these are all in short the required uh, you can say components, and these are the one which acquires the data. So when you acquire the data, the next step is the data processing, which is done through our main microprocessor, that is Arduino Uno. So this does all the processing, and then it is transferred to the GSM module, and after that the data is transferred to the mobile phones. So these are the basically four steps which have to be done uh, for a project. Yeah, next please. Okay, so these are the main components which are required in our project. So the first one is rain sensor, which detects the precipitation, as I said, and then it converts the data. For example, if more rain is coming, if there's more rain in a particular area, so it detects the changes and then it acts accordingly and it sends the data to the UNO. And the next is DHT11, that is the digital temperature and humidity sensor. So, as I've mentioned earlier, so these are the two main sensors which detect change in humidity and temperature. The next one is the LCD screen, as you can see on the screen. This screen is used for, means we use it in our mobile phones and all. So basically, the data will be displayed on the LCD screen. Next is Uno board, which is the main component or of our project, and the next one is uh, uh, GPS module. Sorry, so GPS module, it is used for tracking the location, and yeah, that's it. Next, please. So these are the two main IDs which we have used. So the first one is Arduino and the next one is Proteus. So Proteus software is used for making the simulations of the whole circuit diagram, and Arduino is used for implementation of the coding. So yeah, Proteus for use for the simulations, which the online simulations. We do it on online as it is not possible to make it uh, physically due to COVID virus. So yeah, so these two were the main software. So over to you, Purvaja. Thanks. Thanks everyone.
Thank you, Janvi. Janvi gave us an insight about the background and the problem statement and proposed methodology. Now, I would like to take us forward with the impact analysis of this project. The positive social impact of this project are early warnings. It acts as an early warning system for public which helps to spread awareness of for what is about to occur. The next is preparedness. It helps individuals to mentally and physically prepare themselves to respond quickly to the given situation. Many lives will be saved. Most of the time, people are unaware and unprepared for what, which leads to a huge losses. Early alert system will help save many lives and reduce damages to the property. The negative social impact of this project. This project will slightly increase the stress of the people. It may create anxiety among the individual due to the imminent event. Next, the impact of this project on this environment reduces post-disastrous effect. Being aware and prepared of the situation will aid to the recovery fast from the post-disaster damages. This project is very economical to implement, but benefits are very high. Negative impact of this project on the environment. Usage of many sensors and energy power sources can lead to more carbon footprints and contamination of this environment. Professional ethics and practices to be followed. Minimum requirement information from the open source are obtained. Data integrity is thoroughly maintained throughout the project. No breach of knowledge or idea. Information obtained is through open source platform. Full responsibility of this project execution is taken care of. System implementation. This project was implemented and simulated using Arduino and Proteus software. Proteus 8.11 was the version that was used. As you can see in the above picture, Arduino UNO and Arduino UNO GPS and GSM module were used to to obtain the location at the same time send SMS to the user. A vibration sensor was used to sense the vibration and a rain sensor was used to detect the rain. And DHT11 sensor was used to detect the humidity and the temperature of the environment. And an LCD screen was used to display the message on the screen. Here is the code that we used to implement the system. The code was written in C language and was implemented on Arduino IDE using Arduino UNO R3. This is the result that we obtained from this project. As you can see in the above picture, uh, when a user enters S, his name and its location with latitude and longitude is being provided, and the different outputs that the sensors gave are being sent through SMS. And here's the conclusion of this project. This system was a breakthrough in disaster management as it can be deployed in smart cities all over the world. Less budget is required as the sensors that we used is very budget friendly. The results show that the disaster management SMS alarm system was a success. Future scope. The future scope in future we would like to take this project and further implement and enhance using Arduino, artificial intelligence, and Internet of Things, dynamic adaptation of modules, and using automation. This is the reference that we used to build this project. Thank you. Now I would like to show a small simulation of this project. This is the block diagram that we simulated. This is the Arduino, this is vibration sensor, this is rain sensor, this is a GSM system, and this is GSM module, and this is DHT11, and this over here is an LCD screen. This is the Arduino code that we used in this system. Now let us simulate this. I'll run this system, and as you can see, we get two terminals over here. One is a receiving terminal and one is a sending terminal. Now in the receiving terminal, it asks us to send or type S. So when I press S from my side, or when a user presses S, it gives the location and with longitude and latitude with the name of the user. As you can see here, the terminal, sending terminal or the GSM module just accepted our request and it gave our name with the location, latitude and longitude. Now it will give us the values of the sensor. First comes a rain sensor. We have used a toggle switch here to to measure the sensor data. Like since it is 0, so we get no rain and no vibration. When I change here to 1 and here to 1, so we'll get changes accordingly. See, as you can see, it got changed and it shows it's raining. And at the same time, for vibration sensor as well, it shows vibration is detected. So this is the system we implemented. Thank you so much for attending this presentation. Thank you so much. Have a nice day.